So, what was life like in a Western industrial city like New York, London, or Paris? For the most part, it was disgusting. We have to remember that for the first half of the 19th century, there were no toilets, there were no sewers, no running water, and no concept of the germ. People still believed that disease was caused by miasmatic rot and stench, and there was plenty of stench in the big cities. Picture a very crowded street in central London. People living in the buildings surrounding the street relieve themselves into chamber pots that they dump out the window into the street each day. Horses are the only source of transportation, and they defecate wherever they want to. As I said, there are no sewers, no trash collection. So, day after day, year after year, the poop and the pee and the trash and the skinned animals that residents slaughter for food, every imaginable disgusting thing is just thrown out the window and into the street. On top of this, most people in large cities live in squalid conditions on the brink of starvation. People sleep three, four, five to a bed. There's no privacy, no way to get clean, and disease is rampant. Life for the average person is pretty miserable. And into this environment arrives the cholera bacteria. It is an epidemiological perfect storm. Cholera, as we have discussed, is a bacterium that is transmitted via fecal oral route. But what happens when you get it? Well, as you can imagine, it's not good. From the time that a person ingests cholera to the appearance of the first symptoms can be a matter of hours. The first symptoms are horrible stomach cramps, vomiting, and diarrhea. But this is no run of the mill stomach flu. The cholera bacteria causes the body to empty all of the fluid that is present in the blood into the small intestine. So the serum that makes up the blood is dumped into the bowels. The quantity of diarrhea that results is staggering 3 to 5 gallons a day. Imagine losing 5 gallons of fluid in one day. As a result of the massive dehydration, patients shrivel, their eyes sink into the back of their heads, their extremities wrinkle up, blood pressure drops rapidly, and breathing becomes labored. The patient usually turns blue as they struggle to breathe, which leads to many calling cholera the Blue Death. There are numerous stories of people leaving home for work totally healthy and then falling down in the street with diarrhea and being dead hours later. Nothing could be more humiliating or frightening. A truly horrible disease and a ghastly public death. One of the most important stories in the history of the cholera epidemic is the story of John Snow, who wrote On the Mode of Communication of Cholera in 1849 and is considered to be the father of modern epidemiology. Snow surmised that cholera seemed to be localized in the digestive tract and that therefore it must be caused by something that the patient was orally ingesting. In other words, it must be caused by some kind of contaminated food or water, not stench in the air. Snow decided to focus on the water that the inhabitants of London were drinking as the possible source of contamination. The first epidemiological evidence that water was the source of infection was shown by John Snow's famous Broad Street Pump experiment. Following a massive cholera outbreak in London, Snow decided to trace back the source from whence each of the victims had collected his or her water just prior to their deaths. Using detailed reports from the Civil Registry Office, Snow went to each of the residences that reported a death and interviewed the survivors. His detailed interviewing proved that almost every single victim had collected his or her water from one single source, the Broad Street Pump. Snow did find one small cluster of people who died a few blocks away, but when he interviewed the survivors at this location, he was told that they had walked a few extra blocks to get their water from a source that they found provided the best tasting water, which of course turned out to be the Broad Street Pump. It seemed fairly clear that something in the water of the Broad Street pump was giving people cholera. Snow presented his evidence to the city's public health officials, who agreed to allow Snow to remove the handle from the Broad Street pump. Once the handle was removed, the outbreak immediately stopped. Snow knew that this was pretty clear evidence that cholera was not a miasma just floating around. It was a specific entity found in contaminated water. However, most scientists and doctors remained unconvinced. Snow's second public health experiment with cholera also involved water supply and epidemiological detective work. Again, using the city's civil registry office, Snow mapped out every death from cholera that had occurred in southwest London in the outbreaks of 1848 and 1854. In this 5-year period, he noticed that the patterns of infection had changed. Certain areas seemed not to have as much infection, while other areas remained the same. He was not precisely sure what was causing this anomaly, but suspected that it was something to do with the water supply. At this time in southwest London, there were two major water companies that supplied water. One was the Lambeth Waterworks Company, and the other was the Southwark and Vauxhall Water Company. When Snow overlaid the map of cholera infections with the map of the source of water supply, he noticed something dramatic. In the 1848 epidemic, the rates of cholera were fairly uniform for the areas covered by both of the companies. However, in 1854, when the maps were overlaid upon one another, Snow noticed that only the areas served by the water that came from the Southwark and Vauxhall Water Company reported high rates of cholera deaths. The rates for cholera in those who received water from the Lambeth Waterworks was dramatically lower and in fact had decreased over time. Snow realized that the source of water had something to do with the rates of cholera, but how could he explain these anomalies? Upon investigation, Snow found out something that was crucial to proving that the source of water was the key to cholera infection. First, we must understand that both of the water companies involved took water from the River Thames, which flows through the heart of London. At this time period, this was a fairly normal procedure. In early 1852, Lambeth Waterworks was expanded and redoing some of its infrastructure. In the process of these changes, Lambeth relocated its main water pumps several miles further upstream from their prior location. Snow noted that it was after this pump relocation that the cholera rates plummeted. This accounts for the dramatic drop in cholera in the Lambeth district between 1848 and 1854. To our minds, it seems pretty obvious that water that is collected upstream of a city will be much cleaner than water that is downstream. But this was the proof that Snow was looking for. Water that was collected in areas where people were dumping their waste was somehow poisonous and caused cholera, but water that was collected upstream did not contain this poison. You may have noticed that I used the word poison to indicate that there was something in the dirty city water, and not bacteria or germs. The one major drawback of Snow's work was that he was unable to demonstrate the actual mechanism of infection. There was something in the water, but he wasn't able to establish what it was, and therefore he failed to convince many doctors and scientists. Many skeptics argued that this could still just be miasmatic poison in the water. Although John Snow was correct, the incontrovertible proof that there was a specific agent in the water that was causing cholera would have to wait another 30 years until the work of Robert Koch, whom we will discuss later. In spite of this, Snow's work did provide the methodology for conducting epidemiological research that is still used to this day. Using public data collected by governments, like cause of death and coroner's reports, followed by careful questioning of survivors, is the foundation of modern epidemiology.